Let me see what is going on.
Start. I just paused it.
Okay. Okay. Hello, everyone. And thank you for making the sacrifice to be here this early in the morning. So today, let me know if you are getting me, and if for some reason at any point you don't get me, feel free to type something in the chat. I might be able to see. So today I would take you through databases, and hopefully we get through the end. If we are not able to get through the end, then we would discuss on what we can do next. So the questions that you might be asking yourself is like, if you've done storage and you've seen S3s or block storage, you might be wondering, why do we need to talk again about databases which involve storing data? But the idea here is we always have different sources of data. If you don't know that, at least you've seen an Excel sheet and you've seen how data looks like in an Excel sheet. In an Excel sheet, you will have like a table and you have entries, you can enter cells. And then I'll ask you, your picture is also a data. How do you think you can store your picture? The posts you make on social media, be it WhatsApp, Facebook, Instagram, is also data. Like, how do you think about this data? How can we store this data? And because we have different data sources and different types of data, it calls for us to kind of design systems that can handle different data more efficiently. And that is where the idea of databases comes up. So we'll have the different data sources, and then we'll have different systems that will handle different data. So in that same way, it's something that has a technology that has existed for a long time. So we would also be looking at how this technology is also translated into AWS. How does it look like in AWS, which is like the main focus of why we are here today. So generally, we would be going through what you see here. This is, if you kind of look at AWS, what will you see? You will see these type of databases that exist here. So hopefully by the end of this lecture, you will have an idea on what these are and how they can be, where you can actually use them depending on the type of system that you are building. So one of the things that you would have to take from this lecture also is, as you've seen, the shared responsibility models, where they talk about what you are responsible for when you are in the cloud and what the AWS is responsible for. The database that you will see here, you would live with some distinctions of which ones AWS take care of and what extent AWS will take care of the database. Like any database that is existing on AWS, meaning that loosely, can also run on a normal, let's say you get a PC, you can run the database on it. But then the fact that it's running in the cloud, you get the benefit of having the ability to quickly get some of the resources and the high availability, automatic backups, and everything that you've seen in the shared responsibility model. You'll be seeing that here as well. But we won't be talking about this. You will just be identifying how this applies. So, and then what the way I like to present in form of a story. So if you came here, the way I want us to start thinking about a database is, you have your mobile phone and there is an application that is running. Let's just say that the EC2 is hosting the application. And that application stores different form of data. It can store a table, it can store pictures of your friends, like on Facebook. It can then also store your friends on Facebook, and it can store different types of data. So when we'll be going through the lecture, what you should try to identify is what type of data falls where. If you request data from this application, how can which of the data would the application be getting, and why is the application getting that data? What are the benefits of it? So this is loosely how I want you to think about it. So by the time you leave from here, you understand why you would need different data that are tied to this application. So why do we even care about data? I don't know. If you don't know from your end, you must have heard the common saying that data is the new gold. The idea behind it is that there is a lot that is hidden inside data. For example, depending on how I will give you some specific examples that are applied in different fields. Just somebody looking at how you make your post on Facebook, how you write your post, whether you capitalize it, they can actually pull your behavior from your post. Also, this one is what you already know. Just looking at basically the type of groups you join on Facebook, or the types of groups you join, like on any social media, or like in LinkedIn, we can actually tell your interest, and by then we can equally try to deduce your personality by basically looking at this data. And it is the same thing that customers like businesses are using to look at our behavior online, and then they will use for advertisement. That is what they are capturing. So data is very important, and we generate a lot of data every single day. Like you're going through social media, going through YouTube, clicking videos, that there is a lot of data, and as a result, there is a need to store this data efficiently. So let's get into the nature of data. So we start with structured data, and I want you to think of structured data like an Excel sheet. So if you have an Excel sheet, it's a structured data, and you can think of it like, let's say you have I identify everybody in Wirfon here, and I say, okay, everybody will have an ID, just like when you were in school, you would have a number assigned to you, and when they reach that number, you answer present. This is your number, and now this is like a department ID. So we have the ID. This is the student ID, and then we have the department ID. Let's say someone is in networking and someone is in infrastructure development, and then you have the first name and the last name. So this kind of data is structured, it's highly structured. You can, once you come here, everything around this row will be pertaining to one information. And then it is easy to analyze. You can run queries on this, and queries you will always associate it with a SQL. And then now you also have unstructured data. When we say that unstructured data, we want to move away from this data that you have one information per cell that you know exactly what this represents, to something like, think of a video. At least most of us must have stored either a video or an audio file in a USB drive or inside our computer. When you look at it, it's just a file, .mp3 or .mp4 or .wave or .whatever. It's just one file. What kind of file is it? Can we see say what the structure is inside the file? But that is still, so that is some sort of unstructured data, and you will store that data as a blob. The one way that I want you to think about unstructured data is that you cannot just go rightly and modify a unit like this. So we have lots of different types of files that places where you can store this, and S3 is a typical place where you store this kind of unstructured data. Like you take your media files, you can just throw them in S3. And of course, you can, I mentioned queries in the other slide, and you can equally query this, but we're not going to get into so much details on how you actually will be doing this in S3. Then we have semi-structured data. So it is like a hybrid of structure and not structured data. So how do you think about this? I know the common example that they often give is JSON, but it's usually, the main idea behind it is that you have key and a value. Like this is a key here, this ID is a key, and this is a value. And then location, this is a key and this is a value. And now you can see here, it has a latitude and longitude. They are stored together. This is the same file organized differently, and you could start adding more values into this. This is where the idea of you have semi-structured. You have semi-structured because you can identify, you have keys here, but then you can start growing this, and you can be losing the structure gradually. So it is more flexible. And just let's think of one typical example where you would store something like this. Think about the number of posts people make in a day on Facebook. Let's say the ID is your username. Your location is where you live. These two things don't change. But then the number of posts you will make, the ID of the post that you make. You will make one post in the morning, you make another one at lunchtime, and you make another one in the evening. Someone might be posting every hour, or somebody, they might not post at all in a day. So you will see how this number can be growing and changing. Please let me know if you are still getting me. Can someone confirm you are still getting me?
5.5.
Oh, thank you very much, Silas. Okay, is there any question so far? Okay, no question. So let's get into database then. So what do we mean by a database? So the idea there is that we want to have an organized structure of data. And the reason why do we want to organize it? So that we store in the computer, we want to be able to access this data in an organized fashion. So database is not like just throwing data inside your computer and putting them inside a directory. Here there is now a management software around it. So you can think of it like you have data that is stored, and then there is a system around it that helps you manage this data. It helps you check how you can access this data. You can find out what is inside this data quite quickly than the way you usually go through directories in your computer. And then together you have now most of the companies that offer this, they will offer like a combo. So there is a space, and there is a database design, and then there is some software application that runs on top of the database. And it's not like always the case. You actually have some database management systems that will run on top of different, like basically database is just the back end, and then you have some of the applications that run as a front end. Yeah, Ban is pointing out that if you're not able to talk, you should feel free to type. You can also type your questions in case you are not able to talk. I will be able to see your questions. Okay. So you have different types of databases. And the reason why we have different type of databases, as I mentioned earlier, is because we have different type of data sources, we have different type of data, and we also have different ways that we want to manage our data. You can manage your data just like you think of it, that your computer has a hard drive, and which is a disk, and then it also has a RAM. There are some databases that will prefer to run in a hard drive, and there are some that will prefer to run in the RAM. The reasons are tied to the type of applications. So the purpose of the applications or the would tell you what type of database you want to use and the features that are tied to it. And then we would have SQL database and non-SQL database. So SQL databases are basically relational databases, the ones that looks like Excel. You can directly run queries on them. But then the non-relational database, the NoSQL, which is basically like not on the SQL, the structure is slightly different. And SQL here is basically called the structured query language. So you have the data sources also help decide the type of database you are going to use. And you can think of it like, let's just say, I don't know, let's just think of data like friendship data on Facebook. What is the best way that we can store people's friends data on Facebook? I am your friend, you have a different friend, your friend also have friends. Can we store this as a table? if we start storing your friends as a table, how do we store? You might have 100 friends, I might have 1,000 friends. So if we want to put it like an Excel table, how many rows would this table has, or how many columns would it have? You can see how like it starts becoming a little bit complicated. But then we can say, hey, if you have students in a class and you want to record their marks, then yeah, we would easily get data in a table. So this type of data that you are exposed to will basically help you in making your decisions, and that's basically how businesses work. It is not as if business will be, oh yeah, we prefer to use this type of, no, it is a business problem. For what problem, the problem you are solving will determine the type of database that you're using, and you can actually, one application can actually run multiple databases. So, and then you will see, you'll be going through like online transaction processing, which this one goes right into like the core idea, the idea that you can update the data, you can insert and delete the data in the transaction. Think of it like the associated cost. How much of a cost is it if you want to delete an entry in an Excel sheet? Then you can also, another way to think about it is, if you have like a picture and you want to delete, like, let's say you take a picture of your face and you want to delete, let's say, your nose, or let's just say something, there was some dead pixel in a picture. How do you really delete it? We can tie this here to be, and I want to think like, the easier way for me that I want to think about it is how much you can offset, you update, you insert, and you delete information. I know it's like the example here is how like it's tied to the bank account. You know, you have a bank account, you get money out, then your account is easily updated, and all those kind of the thing. There is things like consistency in how the information is updated. If there is an error, what happens? Will it be able to roll back? All those kind of things are tied to this, but you don't have to worry about those type of details here. But then you also want to know that there is also the online analytic processing. We are going to see a little bit of this when we get into the data analytics sections, and I would throw a little bit light on this. So let's look at relational databases. I mentioned that you can have two broad categories: the SQL based and the non-SQL based, and the SQL based are the relational database. So I mentioned that you think about it like simple. We've gone back to the same table example, but they are built to store structured data that is highly structured. The schema is clearly known. And now, thinking of the structure here, this will always be IDs. The data type here would always remain the same. This one, this would only hold department, and then you can specify to be like, hey, the length of the departments is going to be, let's say, I don't know, 12 characters long, and then you can define the first name, and you can add a number, and you constrain to be like, hey, this is always going to be a string, or it is going to be an integer. You wouldn't be able to add any other thing there. You try that, it is going to throw an error. And this helps your data to have really file consistency, like as a table is growing. And you have number of rows, you can constantly increase the number of rows, and then you have columns too, which are called fields. You can easily not be adding a column into it. You have to design this ahead of time if you are building the database, but most of the time you can easily append a row to it. And then the data in this case, in this database, is usually stored as multiple tables. But then the multiple tables are connected. And the reason why they will have multiple tables that are connected is that you don't want to repeat the same information. Let's just say that if we were storing like this student information, and these students belongs to department, there is no need for us to start adding department information here, which is basically repeated. What you could basically do is, if this information belongs to the department, let's say we have students and student belongs to departments, there might be 50 students and there are only 2 departments. Instead of attaching all the department information here, you just create a table, which is a department table, and then you can connect this table to this by this key. And this is a primary key, and by primary key, it means each of these number can uniquely identify each of the rows. This one is the foreign key. This is foreign here, and because you can use this to identify things in the foreign table. For example, we want to ask where language, which of the department language is from. We say, okay, it's NO1, we don't know. Then which department is NO1, we come here, is networking, and then we can check if there is a contact email for that and the phone number, and we reach out to that department. So that's how you should think about relational database. And then we have, now we have relational database as a general description. On AWS, what are these called? How do you identify this? On AWS, it's just called AWS RDS, which stands for Relational Database Services. So the same relational database that you have anywhere, you have it on AWS, and it's called AWS RDS. So it's a SQL managed database. Basically, when we say that it is managed here, it means AWS takes care of a lot of things for you. It makes it quite easy for you to set up and operate and scale very quickly. For example, you don't have to provision an EC2 instance and start to install a database and be patching your operating system and updating the database. AWS will take care of those for you. And here, RDS is compatible with the online transactional processing workload. So in AWS, these are the type of engines that you will see on RDS. You have Aurora, MySQL, PostSQL, MariaDB, Microsoft SQL Server, and Oracle. And you might be wondering, why are there so many of them? These are specialized for different purposes. If you run a lot of Microsoft products, this is probably what you potentially have been using. And because AWS just provide an engine, it means you can pick any of the compatible databases that you have been using in your application elsewhere, and then you bring it into AWS. So that's the main idea behind this, providing what people are already familiar with, and then they can just use it in the cloud. Advantages of deploying using an RDS than an EC2 instance. As I mentioned, you could run your database in an EC2 instance, but you will take care of a lot of things. For example, if your data suddenly start growing so much, what do you do? If, let's say, the application that are accessing the database, they start growing and scaling like across multiple users, how do you deal with it? So AWS handle these things, and that's what the advantages that RDS will provide over using an EC2 instance. Like, it is easy to administer, as I mentioned. It is highly scalable. They can scale it up or they can scale out, basically increasing the size of the compute, or they can add so many tiny little computes that are coupled together. High availability and durability. It's also fast. You can pick the type of SSD, back the storage that is there. It's also high performance, and it is cost effective. So I would be going in to talk about basically talking about some of the databases that you've seen, and we'll see where each of these actually fit. But what you should know, I mentioned earlier that we want to be thinking about how we are deploying a database. When you have an RDS, let's say you're building an application and you have an RDS, the things that you want to consider. Now, let's say you have your application and it's running in an EC2 instance. There are options for different deployment if you go to the console and you want to deploy an RDS. And there is one called the multi-AZ deployment. Basically, from the way you get it, it says you want to have multiple availability zones. So let's look at what happens here when you have a multi-AZ deployment. You have your main database, and it is sitting here in one availability zone. And then you decide to create a secondary database in another availability zone, so they are in the same region. Whenever you want to read, you read from your primary database, and you can write to your primary database. But what is happening in the background is that everything that is in the primary database is gradually being replicated to your secondary database. If for some reason your primary database goes down, this is what will happen. The read and write will automatically switch into your secondary database if you don't have access to this. And you can see how this is important for disaster recovery. One application is down, you have access to the other one. Or you can also think about it for high availability, which means this one is no longer available, you still have access to your application. There is also the second form, which now we talk about multi-AZ. Let's talk about multi-region deployment and how does this differ? Now, you will look at the same concept. We are no longer having availability zone. We say, hey, we want disaster recovery and want to have our applications across multiple regions. So you can have the main database, let's say in the US West 2 in Oregon, and in US East Virginia, and then you have the US one. I think that's, I don't know, that's Berlin or Frankfurt or where. Pardon my ignorance for those in Europe. But the idea here is that if you are in Europe, when you want to write, it will still have to write to US West 2 in Oregon. But when you want to read, you read from the application that is beside you. But then when you write here, there is still a replication, and you can see why this is good. Customers here will experience lower latency. They basically read from the DC region, and eventually, if you have any disaster which happens across a country, it won't completely affect your database. Now, there is a second one, which is read replicas. And you might want to ask, like, okay, read replicas, how is it different from what I mentioned earlier? What I consistently was mentioning here was disaster recovery. It doesn't mean that this person won't read faster, but it is expensive to deploy this. So if you don't have an application that can handle this, alternatively, you can do a read replica. And read replica is meant for performance. So which basically means you want your users to be able to get access to the results that they're looking for quite faster. How do we set up read replica? In this case, we have we still deploy our application here, and then we tell the application to replicate. And we can do up to, I think, 5 replication. But let's see, we have this replication here. Whenever you want to read, it will read from the replicas, and it will also read from the primary database. But when you write, it writes only to the primary database. This is still similar to what we saw earlier. But the main distinction here is that if your main database goes down, you no longer have access to the write. I think you will still be able to read, but then your data will stale from here. I might be wrong, but you can confirm that this is the case. So what you should pick from here is that there is no automatic failover. So you would have to go in yourself and try to figure out which one will be your primary database so that you should be able to write to. And These are distinctions that you should ensure that you understand. Do we have any questions? I want to hear someone ask a question now. Please, this is a good place to ask a question. Or if you don't ask, then I will ask a question and just pick someone at random to answer.
That sounds better, Joachim. Maybe to keep them awake if they are sleeping.
Okay.
Hope not.
That's
Hello.
right. I was. Okay, yeah, someone is asking a question. Good.
Hello.
Hello.
Yeah, for this read replicas, yes, I just wish to inquire for this replicas. So there is that alternative that if you lost the primary database, you can decide to choose from the replicas which one to convert as your primary and start storing your data again. So it gives you that access.
Yes, that's right. You can decide which one you want to promote to be your primary.
Thank you.
Yeah, that's a good question. Yeah, so the distinction there is that you manually have to do some work. It is not automatic. And you imagine that if you forget, and let's say you are out enjoying vacation like most of us will do, and then you are the only one who handles your application, and then it goes down, and you have to manually do this. So it's a disadvantage, but it doesn't mean that you should not use this. Actually, there are lots of advantages to using this too. Okay.
Thank you.
Thank you very much for the question. Can someone ask again a second question? Okay, I will just pick someone and ask. Let me see. Okay, Balon Leslie. Leslie, are you there? Is Leslie there? Okay, Leslie is not there. What about Herman? Herman, are you there?
I'm sure Herman is there.
Yes, I'm there.
Okay, Herman, I want you to tell me if it is possible that we can use both multi-AZ deployment and read replicas at the same time in the same application.
Yes, I think it's possible. And
How would you? Okay, yeah, go on.
as you say, if one availability zone is stop working, we can manage it with the other one.
So how would you have read replicas and multi-AZ deployment at the same time?
This part of course, I need to understand it very well because I was not very focused on this time.
That's okay. I did not actually explain that, but that is from the first slide that I was trying to show that you should be thinking about how like build this as a mental picture of an application that connects to multiple databases. It should be possible that you can do that. For the details, I don't think that we, as the practitioner level, you need to care so much about the details of that, but just know that that is possible. I just want you to answer a question. So
thank you.
thank you very much for that.
Yeah. Thank you.
Okay, so let's look at
Just a moment, Joachim. Yeah, I think I just want to add one thing regarding, you mentioned replication for read replicas and also replication in multi-AZ, right? So in multi-AZ, the primary database will have data replicated to the secondary database. I just want to stress that in this situation, you have what is called synchronous replication in that case. But for read replicas, it will be asynchronous. And when we say asynchronous, it means that there's some delay in which the time is written to the read replicas, a little bit of delay, maybe not noticeable by many people, but there is some delay. And for the case where we have multi-AZ deployments where data is replicated to the secondary database, it's always almost instantaneously. So that is synchronous replications. So I just wanted to point out those two terms. Yeah, for those who can catch that up. Yeah. And then we'll also share that some links on that. Yeah.
Yeah, thank you very much, man. I hope that it made sense to all of you there. And you can think of it from, you can think of it here that we say, if this goes off, when the data is replicated here, is not always, but what Ban is saying, if you don't get what the terms actually mean. When you write the data here, it takes some time. It's a tiny little bit of time for data to get here. So which basically means if you are reading from here and new data has come, it is possible that you can read old data. Let's just say that I make a post on a Facebook and I made a mistake in my post and I go and edit. You might still be having the old post with a mistake, and until sometime that it will come and you have like, oh yeah, he changed what he wrote. Okay, so let's look at the we are still continuing with the RDS.
Hello.
AWS.
A question, please.
Yeah, go on.
Yeah, is that replication in the same availability zone, or it goes to other region?
Very good question. You can replicate in other regions. I do not think that you would get the value in replicating in the same availability zone. You were asking if it is in within the same region in different availability zones.
Yeah.
Is that a satisfactory answer?
Yes, sir. I get you. Yeah.
Okay.
That it makes sense to do it in another region, not necessarily in the same availability zone.
Yes, but you can do it in a different availabilities, within the same region, but different availability zones.
Okay. Thank you.
Okay, but Alon Leslie agree that he is there. So I'll ask him the next question. So let's look at Amazon Aurora. So this is, as I showed on that slide, you have different, you can deploy different databases in RDS. So basically there are lots of different SQL-based databases that can run on RDS. But then why do we have different ones, as I mentioned? So we look at Amazon Aurora is basically, this is the like AWS proprietary database. And by this proprietary, I know this term might be not even make any sense if you don't even know what other things are available. Like there are open source databases that you can use, like you can use Postgre and MySQL, which basically means you can download them from online, install it in your computer, and build your own database. You wouldn't be able to do that with the Aurora. But then Aurora is compatible with Postgre and MySQL. So if you have applications that we are running on this, you can easily migrate them to, it basically means you can easily migrate them to Aurora. Then you have, it's also fault tolerant and self-healing storage. It basically means here that if you have, let's just say there is you're making data transaction and there is an error in it, it will be able to roll back and get you to have the exact data that you are supposed to have. And so self-healing means like you can have, the thing is this data is replicated. So consider that you replicate the data and there is, let's just say that there is some fault and there is one of the file is corrupt. It should still be able to know which file was latest and which file has more of the information. And you can think of it like the average of the information. It will figure out that this is where the good information is, and it would get that information to the file that is corrupt, and that is where the self-healing comes into play. And it's cost, they say it's cost effective. So this would definitely come from you. It's not about just what you pay. It comes from all the costs that you would have if you are trying to support other databases and all the labor that you have to put into it. When you combine that, you will realize that Aurora is definitely cost effective. And because AWS actually supports it and maintains it quite well, it makes it really good for a lot of enterprise applications, because you have your customers that are going to be accessing these applications. You don't want anything to really get wrong with go wrong with this type of data that you're handling. And then you have software as a service. These are these softwares that are constantly running out there, maybe like Dropbox or any other one that you know. It will make it nice for them to use like Amazon Aurora, and then other web and mobile gaming applications. Then so this is picture here that basically shows that summary of Aurora from the AWS website, like its performance and availability. And it says highly secure and fully managed. These are basically how, because AWS manages it, there is a lot of isolation in terms of network, but just pick these tops and understand. You can read these ones. You don't have really, if you cannot figure out exactly what it is really trying to talk about, that is totally fine at this level. But what is important is for you to understand which cases you should be using Aurora, and how compatible that is compatible with RDS, and what it offers compared to you using other RDS database. Okay, so you might be wondering, like, okay, we're talking about having a database on AWS. Then what do you how do you even get the data into it? So yes, you have a database on premise, and then you want to move data you want to have your application running on the cloud. You have database migration services, and if looking at what we have, like with the RDS, you can choose to move your data to Aurora, or you can just move directly to RDS. So the Amazon RDS can support much more, like the SQL Server, MariaDB, and the Oracle. And then the ones that you can migrate from on-premises, they can go to Aurora. And what I want you to also remember here is that it's not only migrating data from a on-premise to the cloud. You can also migrate data within AWS itself. So now let's go back to our application, and then I tell you, we have this application and it is running. And let's just think of a simple case that you are here and you have your favorite, let's just think of your favorite video on YouTube. I know this is probably not the example I should be giving here, but that you constantly watch all the times. Every now and then you go and watch it. Every now and then you go and watch it. The question I want to ask you is, do you think it is fair that every time you want this video, we should hit the database to bring this video to you? I will ask Sally to answer. Sally, can you get me?
Yeah, I'm here.
Good. So based on this scenario, where I am saying you have your favorite YouTube video, like me, I like to go and listen to Lontum Yof. Actually, there's a Lontum here, so he will answer the next question. So do you think it is fair that every single moment I want to watch this video, a database should be hit? Sally, that's your question.
Yeah, if the resources are there, why not?
Good. If the resources are there, why not? That's a good one. But then this is a problem with that. The problem with that is if you think out of the box, you are like, no, you should not do that all the times. There should be a way for us to identify what someone wants all the time, and then we just make it available close to them, so that when they are coming back for it, you no longer have to go and be like, oh, let's go and look for what he's looking for. It's like, it's just available here, right in front of you. Just pick it. And that's the idea behind databases. We're trying to look now at caching. So if there is something that you watch a lot, there is it's been thought about it, and it's like, this makes sense. People do this because think about it. If it's something that would take like a video on YouTube, and let's think of that, the internet is not as good, and it has to take, if you are watching it from scratch, it takes 5 minutes to load your video. Every now it will take 5 minutes. So if we cache it and you want to watch it, it might take half a minute. So that's the idea behind caching, which is we don't want you to consistently hit the database, because there are a lot of different reasons. We might just want you to have the result quickly, or the database might just be heavy with a lot of things that are going on, and we don't want it to always be hit. But there are really lots of good scenarios as to where you want to cache something. Another good example is, let's say we're talking about watching Netflix. You know, Netflix is common now, or watching African Magic. The movies that you watch, if in Cameroon everybody's watching similar movies, then those movies will be cached around there, so that when you watch the movie, it is easier for you to load the movie. So that takes us to another type of database, which is caching. But the ones I'm talking about here, these are the ones that are compatible with RDS. So they are compatible with the Amazon RDS. So you can think of it like, sorry, they are compatible with SQL. But you can think of it like RDS, where it's like the same way that we have RDS and they are managed. Amazon also manage these ones. So we have, and the ones that we have Redis, the ones that are compatible with Redis and Memcache. So basically what this Amazon Elastic Cache basically provide for you is the capability to run this open source database system. But the main thing behind it that you should pick from here is that when you use Elastic Cache, it is compatible with Redis and Memcache. And the idea behind it is that you want to get resources closer to the customer. And the way you do that is by caching the information. There are different ways that the information is cached, session store, and then but the information that is mostly cached, especially information that is located to specific location. It could be like geospatial services or real-time analytics. They will benefit a lot from this when it's like we want to pull information quickly. And as I mentioned, AWS takes care of everything around it. So all you have to do is just provision. Then now let's get into non-relational database, which I said they are NoSQL database. Does anybody has a question for now? We are moving away from SQL-based database. If there is silence, it means there is no question. I assume that everybody is understanding, and then I will ask a question. So non-relational databases are basically databases that started coming up to say, hey, not everything is SQL. So it's, you can say NoSQL or not only SQL or whichever of the favorite acronym that you picked along the way. But basically the idea here is that we don't want to store the data just in the form of SQL queries. Why? Because we want to have a lot of flexibility. We want to be able to scale. We want to have some optimization and high functionality. SQL databases, as I mentioned, is you have tables and you want to ensure that tables are not having repetitive information. That they say that tables are normalized. And then when you have that, it has some limitations into what you can do. But then let's consider that you want to store simple things, your pictures. How are your pictures stored? Let's say everybody's profile picture is stored by Facebook. What is the easiest way to store the picture? It would be your Facebook ID and then your picture. But let's keep the going. So the idea is you want to store data that is frequently changing. And if you did not cache this from a relational database, it means there is a problem in relational database if your data is frequently changing. Why? Because you store your data in like 50 different tables and they are all connected. If one thing changed in one table, you might have to propagate that change through 50 different tables. With NoSQL, it's not so much of a big deal. Now, look at this data here. This is like a semi-structured data, what you will commonly refer to as a JSON file. But let's look at these documents. You can see here, this one has a few keys, and then this one has more keys. If we were in a database, based on what I explained earlier, you see how hard it will be to keep these as an Excel sheet. Which one will be the row, which one will be the column, and how do you manage now because this one will have rows that this one doesn't have, or will have columns that this one doesn't have, and then you just keep not even sure of what you should track in this data. So this is where NoSQL really excels. So NoSQL in AWS offer lots of different types of NoSQL databases, but the most popular is DynamoDB. And DynamoDB is a key value database. What is peculiar about it is that it is significantly fast. It provides single-digit millisecond performance, and you should know this. Keep this in your mind, because when they would ask non-relational database, they will also throw terms like this. And then it is also serverless, which basically means there are no servers that you really provision. You don't have to provision anything or patch any server, but AWS takes care of this. AWS will be the one running whatever server they want to run for this, but you are not responsible for anything. You don't have any software to install. All you have to just do is store your data. And then it can scale out really so much. It can handle a lot of requests. So this basically looking at how data is accessed. And you might be wondering, why would there be lots of trillions of requests per day? As I mentioned earlier, data is very important, that you can have this much request in a day for some specific applications that need to have access to data. And what happens if it is having like lots of requests coming at a time? Can it be able to satisfy all those requests? Yes, it will be able to do that. And it is fast. It's still properties that we pull from AWS, and it is consistent. So if you have to go with something, please single-digit millisecond latency, keep it in your mind. For example, process, you need it. You can write that down. Then it's used commonly as backends for mobile web applications and for serverless applications. So this is more of a cloud native database. And another one, as I made the way, I will take you back to when I was talking about Aurora. If you want to think of a difference between like why you have RDS and RDS offer the other one, the other databases, direct RDS, and then it offers Aurora, you can also think of it like if you are building a native cloud native application, it is advantageous for you to use Aurora. It's built for that. And then RDS has a familiar things that we know already. So DynamoDB can also be used in banking, and you can think of it like when you go and scan lots of your documents and you give, they will store this, and then they store you have your ID, and the number of documents can grow, which I mentioned, right? The key, you have the key, which is the ID, and you can have your list of documents grow based on your specific need. And this is added here. I will let you go through this, and if you have any questions, you can definitely ask. So now, I asked Sally last time if she would think that is a good idea to constantly hit the database. You will see that this is a common thing that we are asking now and then. I mentioned just a couple of slides ago that if you are working, you are thinking of relational database, you think of the Amazon Elastic Cache Services. It will help you cache data that you are pulling from your database so that you can easily access that data without really hitting the database. It is the same concept here. DynamoDB actually have a specialized caching service on top of it that is called DAX, DynamoDB Accelerator. What is the result of this? It actually increases the performance of DynamoDB again. So think about it. It's already fast, and then you use DAX on top of it. So why did AWS build this and then build DAX? It was the same purpose. Some application might need faster services, and a lot of some result might be repeatedly accessed. And as a result of that, you want to put something in front of your database. And you can see how this is just bringing the concepts together. You have lots of tables in a DynamoDB table, and people are accessing. Then you cache the ones that are accessed more frequently, so that if this person requests it, you first of all check it in the cache. If it's found there, you no longer go to the database, just send it back to them. It's almost like when you go to your friend's post on Facebook, and then you move to another friend's page, and then you want to go back to your other friend's page. Facebook doesn't necessarily have to go back to fetch this information. It might be cached right in your in their cache. And mobile devices have this cache behind. We probably don't always notice it, but they always have. Okay. Now, let's also think about it. We mentioned multi-AZ deployment for relational database. There is also a similar concept for DynamoDB, which is a NoSQL database, which you could have. We're talking about DynamoDB global tables. So these global tables, they are tables that you have access to just from the name, like they're meant to be accessed globally. But then let's look at it. You have one deployed in US West 2 and one in EU West 2. The user can read and write, but there is one distinction that I want you to take from DynamoDB global table. Unlike the other situations where I explained that you always have to write to the main database, you can write to any of the global databases. If you are in Europe and your writing is just going to go to that one, and if you are in the US, it will go to the one in the US. And then replications happen between them, which is a two-way replication. This one replicate to that one, that one replicate to this one. And AWS, they will be saying it is an active replication. Please do note this, and I think it is a very interesting comparison when you just put the two databases, and then it also helps you build a picture in your mind. Is there any question?
Yeah, I have a question, please.
Yep, go on.
Just back to the scenario where we cache, that is, it caches what we have been accessing often, like where we have the DAX. In this case, do we have like, can we compare it to like where you have a YouTube? Maybe it's like on your mobile and you have some particular songs or that you play often, and then it automatically collects these songs and forms a playlist for you. And each time you play another song, maybe 1 or 2 times, it automatically adds to this playlist. Could that be a scenario? Could that be compared to this case?
So if we want to make that comparison here, we are saying that it is caching your playlist, right? You are thinking like, okay, it caches your playlist, and then anytime you want to play, it just checks your playlist.
Yeah,
yes,
it automatically pops up on your screen, like that playlist. Each time you open YouTube, it comes up before other suggestions are coming.
Yes, I would agree that it can be compared here, but I would try to compare. I would try to ensure that we have like we don't misunderstand the concept. So how YouTube suggests songs to you depends on what people who played the song you are playing played next. And you can think of it like if you are in Cameroon, whenever you play Mr. Leo, it's more likely you are going to play Salachiel and then you play Loco. I might be wrong, but that's what I would likely do. So YouTube gradually realizes that people in this area, this is the pattern, like these songs are related, and then it builds a graph around it. We would explain what a graph is later. But then it's like so the recommendation system easily have these songs around. Now, those songs, the way you see YouTube, so all the music in YouTube are stored in a database somewhere. But the nice thing is that they use a global network. So they can cache the songs that are played regularly in Cameroon in their caching services that is closer to Cameroon. So that whenever you want to access YouTube, it is not going to pull the song from a Google server that is in the US or a Google server that is in Iceland. It will cache from something that is closer to Cameroon. And I don't know if you're getting this, this is in line with what you are thinking, but I think is going in that direction. That is basically how caching works, so that you don't have to wait for a long time for the music to load. And algorithm is that those using cache services online use internet data, YouTube for instance. Okay, yes, it uses internet. So when you are caching, used by the memory. And I would tell you that let's think of what is cached inside your phone. Let's say that you play a video in YouTube, or let's say on Facebook. Actually, let's think about Facebook. You play a video on Facebook, you scroll down your news feed, and then you come back to play that video. Facebook doesn't go to load that video from the database. The moment you play that, it is added to your cache. And when every cache has like a time to leave, which basically means if after 5 minutes he doesn't access this video, okay, we can delete it. So it's something that you should keep in your mind. So it will use a storage in your phone. But Alvin, what you should know, the idea behind caching is actually to help you reduce your usage of data. Because if you play a video and then it is cached, then you play the video again, it doesn't consume your data, right? But imagine that every single time you play the video, it will consume the same amount of data. Your data will be going much quickly. And that is also one of the ways that companies try to ensure that you don't use a lot of your data. They help you because they know like you should use your data for something else, but then you have memory in your phone will have some memory that can cache this application in it. So, and what you should pick from here is that there are lots of layers of caching. It can be cached in your phone. It can be cached within their services within the country or within a region like in West Africa, or like different layers of caching. And as you get in your journey with AWS, you will realize how much this is actually a very important concept. Yeah, thank you very much for your question, Silas.
Thanks for the clarification too.
Yeah, excuse me, I have a question.
Yeah.
And I don't know if you can come back in
This slide.
no database about banking and retail. That
Okay.
yeah. So is it possible to use so I want to know if it's possible and how it's possible to use database in some company like hospital, for example. I take example with in hospital with CCTV, for example, or I get education, for example, if you have many students and you want to store a document or thing you have a relation with student, or for example, if you go in this big supermarket, you want to buy food, how can we use a database, or how database can help in this kind of company? Because you just speak out just about gaming, retail, banking, and finance. So is it just this company that we can use database, or there's other company who database can help?
Database can help almost every company. If we take go to the example that you're asking, you have students in a class. Think about, like, when you have students in a class, you have information about students. You have a student ID, you have a student's name, you have the student's address, then you have the student like emergency number. Then now you also have the terms. You have the first term or you have the second term. These students also have the marks. There is one way that you can choose. You can decide that you are going to store all this information as one big Excel sheet, or you can choose to start splitting this information across different tables. And that is how the idea of a database start coming in, where it is, my information is growing beyond having a single Excel sheet. So you need to start splitting your information into a database. Much commonly, you will be like, oh yeah, but you see some teachers will just use their computer and store the information in it. That's good and fine. But that is when you are managing just one class. If you're managing one class, yeah. When you start going to the whole school, it starts becoming a little bit complicated. And then if you start asking that you want to manage the informations of all the students within, let's say when the GC is written, it will be quite hard for you to manage the information in an Excel sheet. So the idea behind a database basically means you do not want to have a lot of repeated information, because when one information changes, you would have to go and change it in several places. And let me give you an example in a shop. You ask information about a shop too. If we have some customers coming and buying things from your store, and let's say we have, let me see who is on my screen. Fight Theory is on my screen. He come and buy, he has an ID. He come and buy something. He uses his bank card. We record his ID. We record whatever he bought today. Then we have Leslie come and buy. And then Sally comes and buy. And then different people are buying different items. There are different items in the store. Now, it doesn't make sense that we should store everything as one Excel. Let's say if you have a Samsung phone in your store, every information about the Samsung phone and everybody who buys would be one row in an Excel sheet. Now, what happens if you decide that now when one person buy, you have this information for the Samsung phone, the type and everything on their name. The next person come and buy the Samsung phone, you have all the information too, including the details of the Samsung phone. What happens if you realize that actually the information that you have about the Samsung phone wasn't entered correctly? you would have to go and look at everybody, all the 50 people who bought the phone from you, and you are going to be changing the operating system ID. Basically, what you would want to do here is you want to store your customers separately from the details of your customer and the details of what they are buying as two separate tables from what I illustrated earlier, so that if you want to track information from your customer table, you can easily pick what is an identifier to the next table. And the reason you want to do that is that when information changes in one table, you don't want to change a lot of information at a time. But what I want to leave with you here is that you will have, like, database can be used in any business, and you'll be surprised at how much database is used in applications that run inside your phone. Almost every application, I would say every application that runs in your phone is running a database in the back. I don't know if that's a satisfactory answer for you.
Thank you so much. Very satisfying.
And Mustafa is saying that he thought caching was mainly to reduce latency. Yes, it is. A caching latency is one of them, and we usually think of it that way. But you can also use caching so that you reduce how many times people are hitting your database. It also translates to reducing latency, because if you can get the information from the cache, then you don't have to go very far. But all the explanation we gave caching YouTube videos around Cameroon is also so that the customers will quickly get, but then it helps you reduce how much data you consume. Maybe that's just a fringe benefit. But how much time do we have?
Yeah, I see we have about 15 minutes to go. Yeah, so.
Okay. Let's see if we should just answer some questions, or we should just keep going and then we answer questions. Let me see. Yeah, I'm almost to the end here. Okay, so let's please, if I'm a little bit faster, just let me know. I will slow down. So I already started preparing your mind to tell you, like, hey, there are different types of databases, and we kind of try to understand why they are different and how different information call for different databases. The next one that we're looking at here is Neptune. The easiest way that I often think about Neptune is just from what it says it does. It's a graphical database. And I've shown you a tabular database. But how do you think about a graphical database? It's not easy to see one. But simple example that I already mentioned, you are friends on Facebook. You are you've connected to, let's say, your friends from your secondary school. Your friends are also connected to their friends. And then let's say you have someone who moves schools, they will have friends from different schools. And then you can start seeing how it starts growing. You are the center. You are connected to, let's say you have 100 friends on Facebook. And then one of your friends is equally connected to a lot of friends. And then you might realize, like, 5 of you are all friends with one another. How do you put this in a database? When this kind of structure came up, people realized that if we would want to access this data much more quickly, we want to design a database that is meant for it. And that's when graph databases came up. So Neptune is a fully managed database on AWS, which is responsible for building data which is highly connected. So it powers recommendation engines. And you can think of the example that I was talking about, how YouTube will potentially build a list of music to suggest to you, is by looking at people that are around you. It's a geographic network and the type of music that they are playing. When you play Mr. Leo, what do they play next? What are they likely to play next? And then you could see, like, if you draw like a graph, if you draw a graph of artist connectivity, you will see how Mr. Leo will be connected to Salashel and to Loco. That is where graph databases come in. There are lots of applications for it, and I will let you, when you go through this and you have questions, you can ask. This is a simple illustrations here. Connectivity, this is social network, restaurant recommendations, retail fraud detection. I actually know one application in like in fraud detection, and I will just share this with you. I attended one presentation from Reuters, and they were talking about how they track money laundering. They use graphy ML related to of your graph database, and what they basically use as nodes were bank accounts. So you would have instead of having people connected like this, you have bank account. This bank account is connected to this, connected to this, and what they track was some transactions. You have a transaction, and then you figure out which bank account money went to from that transaction. And by looking at that kind of high level connectivity, which accounts were connected to it, they could easily, not easily though, they could identify some money laundering. And you can then think about, you can then start making your own thoughts about your mind, how you can, what kind of information you can represent as a graph. Maybe the root network in Cameroon, you can also represent it as a graph. So anything that you can think of potentially building it as a graph will fit such applications. And then I was thinking that I would talk more about this in data analytics, but Redshift is also another database that is also managed by AWS. It is built on top of the Postgre. We've seen that the Aurora is built on top of Postgre, but the main thing that AWS brought together is that when you want to run analytics, it is hard to get your data. The data that is good for analytics looks like the data that is in a table. But then most of the table that we saw in relational databases, they tend to be split across multiple tables because they want to apply something that is called normalization in the data. So as a result of that, it makes it hard to pull data to run analytics on. So what tends to happen is you need to denormalize your data and make it like a gigantic Excel sheet. And that is why Amazon built Redshift. It is meant to be fast. Data is stored differently. So instead of looking at data in terms of row, they would look at it in terms of column, and it runs SQL. SQL will run on it, and then you can easily hook a lot of the BI tools. We will talk about BI tools and QuickSight in the data analytics part. But what you should take from here is that it is the warehouse which is very fast and is compatible with data analytics. So this one too, I will also talk about it in data analytics. I do not think of it as it's not a database at all. But what you can take from here is that as time goes on, if you can take from the lecture, from how we were going with the lesson, it's like as time goes on, technology is developed, and technology is developed for different purposes. What happens if I store a table in Amazon S3 and it is not a database? Does it mean I can never query that table? That is where Athena comes in, and I will just keep it for now. Then what I want to add here and remind you is that we mentioned earlier that you should know that you can migrate data. You should know how to migrate data to AWS, and you should use a database migration services. And that database migration services could also help you migrate data from AWS to AWS, and also migrating data from on-premise to AWS. And they can also help you to migrate data from within the same type of database. Let's say you are migrating Oracle to Oracle or MySQL to MySQL, but then it can also help you to migrate different type of databases to different ones. like taking a Microsoft SQL Server to Aurora. And the migration services, they actually like they support all type of databases and migration to anywhere. Like if you host your database in the EC2, you can migrate it to RDS and vice versa. They are low cost and they are very reliable. And I already mentioned that you can migrate data to the same database and different database. So I would leave it here so that we can answer questions. Does anyone have a question? Is there any question?
Yeah, hello.
Yes.
Okay. I wanted just to find out, I don't know, is this information not too much for somebody who does not want to specialize on database in the cloud? Because it's really huge for somebody who just wants to, I mean, I don't know. I thought maybe it's also specializing in database.
So I get, yes, you are right, but you can realize that everything that I mentioned here is high level. It is just telling you that what I've been trying to pass across to you here is to identify the different type of databases and where they are useful. We have not gone into the details of how they are designed and how they are built. And I think those kind of hardcore knowledge will be for those who are specializing. But basically for you to just know, like, let's say if you show up in your exam and it's like, okay, we are building an application that will be looking at root connectivity. What type of database will you suggest? You should think that that root connectivity sounds like a graph. I do not think that this is something that you should not know irrespective of whatever you are doing, because let me ask you, what do you think, what do you want to specialize in the cloud? What is your interest?
I don't really have any speciality, but I was just talking because I know that they are database analysts. So it's in that line that I was, my question was directing to.
So a database analyst would be figuring out things like which type of database should be used. Is that what your question is?
Yeah.
Hello.
I think they should. Yes. Someone else want to take on this. Yeah, go on.
Oh, sorry, I thought you were finished answering the question. I was about asking another one.
Okay.
You can finish with her before I ask after.
Well, all I can tell you, Sally, is that I don't think this is a lot of information. You should have a high level idea of what the services are, irrespective of whatever specialization you want to get into, because I cannot think of any specialization that you will not need to have basic ideas of the database. And that's why I was asking you exactly like what specialization are you interested in, so that we can help you identify how important a database is.
Okay.
Absolutely. Just to add before we come in, yeah. So right. So again, it's having that high level overview, and that's just basic definition. You realize that along the line, there are specialty certifications for those who want to do database, right? So, but as stated, in the area of cloud, it's just good to just have some terminology. Like here, this is just an introductory to know what this is, what is used for. That's enough. Because in your conversations or just sitting and talking, you always hear just high level overview of terms come across. So, and I think this is really what is presented. Maybe the first time can look overwhelming, but if you realize that if you look at it 2-3 times, it starts sounding like, okay, I get what it is. And that's just the high level overview that's needed. Okay. Okay, go ahead, Joachim.
Yeah, Lawi, you have a question.
Yeah, I noticed when we are talking about database, I mean, first of all, when we started with computing and all other services, we were talking about using one region with multiple availability zone. But when you were talking about database, you said you can keep your data in multiple regions instead. And then the reason why they were telling us to put it in one region is to minimize costs. But here you are emphasizing that they always store data in multiple regions. Why is it different in this case?
So let me just be clear. It's not a must that you must store data in multiple regions. The question that you often ask yourself is that, how important is this data to me? For example, if you have a picture in your phone and you have not copied it to save it in your computer, it's not very important, because if your phone dies, you will never have that picture and you don't bother. If that picture is very important to you and you hold it so precious to your heart, you will copy it somewhere. That's exactly what I was trying to tell you here about a database. If that data is very important to you, you want to store it in multiple places. If it is not very important, you can have it in one availability zone. And this is the same thing that you probably have heard about compute, where if you have your application running, you can run it in one availability zone. If something happens to it, you don't care. Got customers, nobody will die. But let's take a step back. How do you think we should store patient records? How do you think Google should store your Gmail? What do you think? Will you be happy if someday you are like, I lost all my emails that I have in my email because Google said they lost the data? Or you want to have, I don't know, maybe patient record is not something that is even tied to if somebody from Cameroon will understand well. And apologies if you are not in Cameroon, but I will give an example that should be important to people in Cameroon. Let's talk about GC certificates. How do you think GC boards should store their data? Like someday GC boards, let's say fire happens there and GC boards that we've lost all the certificates of everybody who ever had GC. You no longer have certificates. That is something that is actually at stake. GC boards, if they are storing their data in the cloud, they should better replicate it. So it's more of like, the importance here is how critical is your data? Or think of it like when an airplane is flying and we have, let's say there is corresponding information that it is streaming of its location. Do you think we should store it in one place? If suddenly we lose that, we will never find the airplane. So it probably like, it is more of like, when you start identifying examples, it is kind of easier for you to be like, yeah, this is something that is critical. I don't want to lose this. And let me see, Yolande said, okay, you see, just emphasizing there are a lot of the practical examples here. Yeah, so the thing is, the question you should ask yourself is, how important is this to me? And then the next question and that's the type of question that I put from the beginning, right? How important is it to you? If you consider that your customers are very important, you want them to get access to information quickly. And maybe sometimes we talk about access to information quickly and we don't get it. Think about it. If you want to buy something on Amazon, and then you go to Amazon and then you click search, and then search is turning and turning and turning for 5 minutes, you're going to stay there. What are you doing there? You will leave, right? And there is a research that Google did, and Google showed, like, if a page stays 15 seconds before it loads, most of the people will leave, and it corresponds to losing customers. Sorry, I think we're out of time. I really wanted us to answer questions, but I appreciate that the class is more interactive. The questions will be in the back of the slide. So if we are not able to answer any, it's still fine. I will still be meeting you guys for the analytics, and you have any questions, you should bring the question there. but it would have been nice if we answer a few questions. But yeah, but I'll send it over to you.
No, that's great, Joachim. Absolutely, yeah. For the questions, just remind others the revision questions. They can look that at the end, and definitely, if they have questions, they can still put them on chat. And I know you're available in the group to pick up any questions in regards to this topic. So, yeah, encouraging everyone to look at them. If you don't understand anything, yeah, share your questions on the Telegram group. Yeah.
Okay, so as if is there any final question?
Sounds is a quiet house. Definitely better.
No worries. We will still be meeting. We will still be meeting. So probably there will be more questions next time. Feel free to bring your questions. That's probably an opportunity.
Yeah.
Yeah.
Okay, let me stop the recording and
okay.